أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. Again, I welcome you all to an exciting physics class. Now, in today's class, we will talk about Archimedes Principle. Archimedes was one of the greatest physicists that ever lived. Okay, according to his principle, is also about fluid. By fluid, we mean liquid and gas. Okay, he says that Archimedes' principle states that when an object, a solid object, is immersed completely or partially, it doesn't matter which one of the two. Once it is immersed, whether only portion of it is completely is immersed or entire object, okay, that's the meaning of completely or partially in a fluid, okay, and this fluid can be a liquid or gas. The upthrust, this upthrust is the force it will experience. If I have a container, for example, okay, and then this container has liquid here, now if I bring a solid material inside, then it will experience a force. The molecules of the liquid will give it a force, and that force we call it upthrust. Okay, upthrust. Up reminds you that the force is in the upward direction, okay, is upward, and then thrust means force. So even from the meaning, we have an upward force acting on the object. Now this upward force, otherwise known as upthrust, is equal to the weight of the fluid displaced. Because when you immerse an object here, if I immerse an object, let's take complete immersion. If I immerse an object completely, then the liquid level will increase, it will go higher. So let's say this is the initial level. I can call this V1, and then this is V2. Then V is equal to V2 minus V1. This will give me the volume of liquid displaced. Okay, then the mass, we know that density is mass over volume, so the mass of the liquid displaced is volume times density, so this will be V rho. And then weight, we know that weight is mg, and then this equation tells you that your mass is V rho. So if you put V rho for mass here, it becomes V rho, and then you have G. So this is the weight of the liquid displaced. This is what we call weight of liquid displaced. Weight of liquid displaced. According to Archimedes' principle, this weight of liquid displaced is the upthrust, is equal to the upthrust. If you calculate the weight of the liquid here that is displaced from here to here, if I get the weight and I have 20 Newton, Archimedes says that this 20 Newton is also the upthrust. The upthrust will be 20 Newton. Whatever you get for the weight of the liquid displaced is the upthrust. Again, this volume, if it is completely immersed, then this volume that you get is also the volume of the material. Okay, it's also the volume of the material. So from Archimedes' principle, we see clearly that upthrust is equal to V rho V. Let me adjust this one a bit. MashaAllah. Now, according to him, upthrust is equal to V rho G, where this V is the volume of liquid displaced, rho, and also, of course, the volume of the material. Rho is not the density of the material. Let's say this object is a metal. It can be copper, metal, okay, and the liquid here is water, for example. We know that the copper has its own density and the water has its own density. So which one am I using here? Here I am using that of water, not the copper, okay? But this volume is the volume of water displaced and also the volume of the material. G is always the acceleration due to gravity. Now, let's say only 1/3 of the because according to Archimedes principle, look at these two words. You have completely, you also have partially. You use this formula when it is completely immersed. But if it is not completely immersed, maybe only a portion of it, let's say you are told that only 1/3 of the liquid of the object is immersed, then the formula becomes U is equal to 1/3 V rho G. Depending on, if they say 2/3, then you put 2 here, depending on what the question says. Okay, now without any delay, we are going to see a problem on this Archimedes principle, an interesting problem. What does it say? It says that a copper block of mass, you have a copper block of mass 0.5 kilogram is hung from the end of a thread and put in water. If the density of copper is this 9.9 times 10 raised to the power of 3 kilogram per meter cube, and the density of water is 1 times 10 raised to the power of 3 kilogram per meter cube or cubic meter, calculate the tension in the thread. Okay, as usual, when you have a problem like this, my advice is try to draw a diagram. The problem says I have a copper, okay, this is a support, okay, this is a support, then I have a wire here, and then this is my copper block, okay, and then this copper block is immersed in water. So it is in water here, you see it is totally immersed, and because it is in water, there is upthrust and upward force on it, you see. Another thing is it has its own weight acting downward, okay. Then here you have tension on the string, so two forces are upward and then one force is downward. Since it is not moving, it is at rest, it is in static equilibrium, and when an object is in static equilibrium, then the total forces in one direction equals the total forces in the opposite direction. So if I take the upward forces, T and U are upward forces, so I can say T plus U is equal to the downward forces. Only one force is downward, and this is with the weight, you see, W. So it means T is equal to W minus U. Don't forget, the problem says you should get the tension. The tension is this T. How do you get T? The second equation tells you that your T is equal to W minus U, and I'm going to call this equation 1, but then I can continue and say this is, let me not say equation 1 yet. I know that weight is just mg, okay, so I can say mg for weight minus U, where U is my upthrust, okay. This is equal to, from what we did here, look at what we have here, what we have here. This upthrust is what? Volume, where this volume is the volume of the liquid displaced and also the volume of the solid. So this is the volume of the copper. Don't forget that. This is the volume of the copper, but then this density should be the density of water, and then G. So instead of U, I can say mg minus, and then my V, this is volume, but the volume, don't forget, is for copper, and then rho for water, and I have G. Okay, good. Moving on, I can continue and say, okay, but before that, I need a little rough work here. I don't like this V sub C, okay, because I'm not giving the volume. So I know that density is mass over volume. So I will make V the subject of the formula. Just interchange this. V is equal to mass over density. So if this volume is the volume of copper, then the mass should be for copper and the density should also be for copper. So anywhere I have V sub C, I will put M upon rho C. So in the next line, I will say my T is equal to mg. Let me bring it here. You see, mg minus, but V sub C, I will not put V sub C, I will put M upon rho sub C, so minus M upon rho sub C. But after that, this is just my V sub C, you see that? Then I have density of water. So I will now say density of water multiplied by G. Now, they have two things in common. If you see M in common, G in common, so I can factorize Mg, okay? Mg divided by Mg is 1 minus, if I take the M here and the G here, I will only have rho density of water divided by density of copper. So density of water divided by density of copper. Moving on, you see, since tension is my subject of formula, it means at the end I can calculate this tension. So the next thing I will do is to substitute what I am given. This M is the mass of copper, and look at what it says, blah blah blah, copper of a copper block of mass this, so 0.5, so I will put 0.5 here, multiplied by my G is 9.81, and then open bracket 1 minus density of water. Density of water, they said, where is it? And the density of water is 1 times 10 to the power 3. So I have 1 times 10 to the power 3 in kilogram per cubic meter. Then divided by density of copper. Where is the density? They say if the density of copper is 9 times 10 to the power 3. So I have 9 times 10 to the power 3 kilogram per cubic meter. Close bracket. You see, these units are the same, so they will cancel each other. So we move on and say, okay, this is equal to 0.5 times 9.81. This will give you what? Press this one first, you see, and you get 4.905. So you have 4.905. Open bracket 1 minus, then you evaluate this one, this divided by this. Look at what you will do. You just press 1, then exp, exponential, ignore the 10 that you have here, okay? Ignore this 10 and just press 3. You see, you see something like this. Then you now press divided by, then 9 exponential 3. See, 9 exponential 3, something like this. Then now press equality sign. 0.11. Since this one is correct to 3 decimal places, we will make this correct to 3 decimal places as well. So 111, and this is equal to 4.905 multiplied by, then you press your calculator again and say, okay, 1 minus 0.111. What do you have? You see 0.889. So this is 0.889, and this is equal to then you now press 4.905 multiplied by 0.889, and look at what you have, 4.36 to 2 decimal places, and this is 4.36, and tension is a force, is in Newton. With this, you have successfully solved this problem. Alhamdulillah. We have seen that according to Archimedes Principle, when an object is totally or partially immersed in a fluid, then the force it will experience due to the molecules of the fluid, which we call upthrust, is equal to the weight of the liquid displaced. If you get this weight as 20 Newton or whatever you get, is equal to the upthrust. And we have also seen a problem on that. I hope this is clear to all of you. Assalamu alaikum wa rahmatullah.